Hello, welcome to my Develop series. My name is Edu Del and I'm working in an action RPG/Tamagotchi game, where the player has to fight monsters while taking care of a creature and solving puzzles. This past week was great. I have received a lot of feedback in Reddit, Twitter, Instagram and Facebook. The community helped me a lot with the dash effect of the game, and showed interest in the game. I also got this funny bug while programming a draggable object mechanic. But I don't want to get ahead of myself. Let's go back to last Friday. After setting up this YouTube channel and upload the past videos, I start planning my next week. For these tasks, I will try to set a deadline of 1 week, except for the audio ones. This week I try to make the player dash animations. Having in mind that there are 8 directions, this will take me 1 or 2 days. I also would like to work a bit in the calm zone of the previous videos. As I said, composing can have a deadline of 1 week, not at least if I want to produce an acceptable song. For design, I need to start thinking about the player objective and background, so I can figure out other mechanics and needs for the project. A basic, temporary interface can be really helpful to start managing the difficulty of the game. One mechanic that I definitely want in the game is draggable objects. For example, any Legend of Zelda game has puzzles where the player has to move a statues to open a door. Programming this kind of mechanic will let me design such puzzles. And as I intend to have the player dash animations, I will need to program an effect for the mechanic itself. I was thinking about a trailer copies of the player, like if they were ghosts. We'll see how it goes. I jump into LMMS to continue the song I saw in previous videos. I would like to come with a part with a different melody. This part can act as a bridge that will lead to a chorus. For now, I'm just making the piano track. Although I'm not completely happy about how this turned out, it's a start. Here is the result. Later, I decided to move to a different task. I started making a test animation for my dash effect. As I don't have the effect program and don't really know how many frames I need, I will start simple. The animation will consist of 3 frames, 1 for anticipation and 2 for the actual dash. I choose the left side view as it's more readable and easier to figure out. For the anticipation frame, the player will lean back and prepare for the dash. The dash frames will be practically the same, but with a small movement representing the wind. The motion will be created by the movement of the player itself, the ghost effect of the dash and this small animation. With these frames ready, I can move on to programming the actual dash effect. But first, I needed to create the animations inside of Unity. I exported the animation made in Sprite into a sprite sheet. After slicing it and configuring the image to show as clear pixel art, I placed the frames that would become the dash animation. This was my first mistake, as later I realized that I needed 3 animations. One for preparation, one for the actual dash, and another for a slide at the end. But I will talk about that later. For the code of the dash effect, this was my idea. An object will hold a pool of ghost objects. These objects will only have a small script and a sprite renderer. When the player dashes, this pool object will release 1 ghost every so often. Once released, the ghost will copy the current sprite of the player and quickly fade out, giving a ghostly trail effect. After completely fading out, the ghost will return to the object's pool. All these parameters, number of goes, release frequency and fading out time, are serialized to adjust the effect. This approach had a problem. I needed to get the player's sprite and pass it to the ghost. I decided to include this dash effect in the player's object. The pool object will grab a reference of his sprite and then pass it to the ghost. The problem was that, as the ghosts are son of the object pool and the object pool is son of the player, they will emulate the player's movement. I could have fixed the problem by removing the player parenting from the ghost object, but the only real reason to having this hierarchy is to have access to the player sprite. So I decided to change the approach. The pool object, with all ghosts as sons, will have a target. From this target, it will get a reference of its sprite. Doing so, I could implement this data effect on other objects easily. Having this data effect object set up, it was time to test the actual effect. It was working correctly, but the test animation was not implemented yet. However, it was a good start. If I changed the fade time variable, the ghost would stay longer. I could even make the effect really subtle, making the ghost fade out faster. Implementing the dash animation was easy, as I prepared an animation manager for the prototype. This is handled by the player controller. When the dash is called, I change the animation. Here you can see the animation manager in action. I don't use Unity Blend System as my animation are frame-based. For now, the dash animation only works when the player dashes to the right. But these kind of tests are great to figuring things out. One idea I didn't told you in the previous videos is that the game will have skill progression. For example, when the player levels up, there will be a choice of improving hit points, dash ability or attack ability. At this point is when I realized that having only one dash animation will not work. Anticipation couldn't be in the dash animation, as if the player levels up the dash ability it will last longer, and the anticipation frame will show up again. This is why I decided to create a pre-dash, dash and post-dash animation. So I jumped back into a sprite to create a post-dash frame. This frame will be similar to the anticipation one, but the front leg will be extended. Making this animation in 8 directions will be a lot of work, but mirroring the frames will speed up the process. Something that bugged me about the prototype is the diagonal movement. As it is right now, the player moves slightly faster when going diagonally. I decided to, as I was modifying the character controller script, make a modification to fix this issue. When the player moves diagonally, an 80% of the regular speed will be applied. This will make the movement speed more stable when moving on all directions. Here is a small test with this diagonal movement issue fixed. I also included the pre-dash and post-dash and tested it in combat. These modifications were pointed out by the community. Something networking helped me a lot, especially the Unity 2D community. You guys are the best! Having a satisfactory dash in place, I started making the animation of the other 7 directions. This process is time consuming, but I'm mirroring some parts to ease the workload. And thankfully, this animation is only 4 frames long. This will be a lot harder when the time comes for doing attack animations. But as this is a personal project, I'm not in a hurry. With all this work done, I can finally move on to the next task. I spent too much time on the dash effect, so I only had time to one more task. Draggable objects seemed like an easy task, as I programmed an interactable system for the prototype. The interaction system will call a draggable component to grab the object. This component will notify the player that an object has been picked, and for as long as the player keeps pressing the button, he will drag the object. This system has some uses, like the collision between the player and the grab object, or even the combined collision of the player and the object with the game world. The rigid body attached to the draggable object gave me some problems as well. I had to increase its mass a lot so the player couldn't push it without grabbing it. This supposedly easy task had some funny bugs. As I didn't freeze the rotation of the object's rigid body, some forces were applied. Such a faster way to move around the world, isn't it? To be safe, I decided to disable the collision within the player and the object completely. This will happen when the player grabs an object, and the moment he releases it, the collision will be enabled again. This seemed to work as the player and the object didn't collide with each other, but they did collide with the game world. However, this raised new problems. At first, I forgot to enable the collision of the object at the end, and applied the same movement to the object and the player. This was a nice approach, but could lead to some issues with the colliders. For example, the player could be colliding with a wall and stop moving, but if the object wasn't blocked, it will continue moving. I tried to fix this problem in different ways, but having two colliders, the players and the objects, made it really hard. So I decided to take a different approach. The player will only have one collider when he grabs an object. The object's collider will be disabled and the players decide to fit both colliders. This approach worked better. There is still some work left to do with this system, but for now it's pretty decent. For example, I will need to reset the player's collider differently depending on the direction he is grabbing from. Another thing I decided to change is the speed when an object is grabbed. In the previous version, this speed was always the same. It didn't matter which object the player was grabbing, so I decided to add a variable to the object itself to determine this speed. I will need to limit this variable to the walking speed, as the poor object can keep up with high speeds. And that was my week. I didn't manage to finish all the tasks, but I'm happy with the progress I made. I'm also very excited about the response of the community to the game's idea. The people seemed to like the idea and gave me a boost to keep working on the game. Thank you! Another thing I would like to talk about is the pet itself. A friend suggested that it could be an octopus. What do you think? Another person on Reddit suggested that the pet could grow and even help the player in combat. All these amazing ideas are great, and as my initial idea was that the pet will grow in different ways depending on how you take care of it, never thought about including skills to the pet itself. For example, if it was an octopus, it could extend its tentacles and grab enemies, or make the player fall if it was poorly taken care of. What do you think? What kind of creature should the pet be? Do you have any ideas for skills or other mechanics for the game? Leave a comment below. I have also set up a Discord server. I will post frequent updates on the game on it. I also post almost every day on Twitter. You can ask questions, suggest mechanics, changes to the game, or just chat. There is a link in the description in case you want to join the Discord server. That's it for this week's devlog. Hit like if you enjoyed the content and subscribe for weekly devlogs. See you next week!